Good morning, everyone. In today's class, we are going to learn how to find the square root of complex number and few other proof sums in complex number. So let us not waste time and let's start with the topic. Finding the square root of a complex number. Find the square root of the complex number. I have selected two questions. Z equals minus 5. Yes, z equals minus 5 minus 12i and then an I. Z is just I. So I'm going to tell you how to find the square root of these two complex number. Now, solution for the first one. The question here is to find the square root of minus 5 minus 12i. So let's put a square root on top of that. And let us represent that the square root of this complex number as, or let us assume, is as x plus iy. So let us assume that the square root of minus 5 minus 12i is x plus iy. Now square on both sides. Minus 5 minus 12i equals x plus iy the whole square. So minus 5 minus 12i equals x square plus I square y square plus 2xiy. Minus 5 minus 12i equals x square. We know I square value is minus 1. So this becomes x square minus y square plus I into 2xy. Now I'm going to equate the real terms on both sides. So what are the real terms here? On the left side minus 5 and on the right side it's x square minus y square. So equating just the real terms, which is minus 5 and x square minus y square. Then equating the imaginary terms, which is minus 12 equals to 2xy. Right? So we are getting two relationship between x and y here. Now I'm going to show you a conversion formula which will help us to solve this sum in a very easier way. Instead of, even these two informations are more than enough to find x and y, but then sometimes you get two values for x and which will take you to each x value will give you two y values if you keep solving like this. If you retain it like this itself and solve, you get two value for x, and for every one value of x you get two value for y. So you will not be able to get a proper answer. So therefore I'm using a conversion formula here, which is x square plus y square the whole square can be written as x square minus y square the whole square plus 2xy the whole square. Because you get, when you expand x square minus y square the whole square, you will get x power 4. You will get x power 4 plus y power 4 minus 2x square y square, and over here we have plus 4x square y square. So result of that will be plus 2x square y square. Therefore, which is nothing but x square plus y square the whole square. So using this conversion formula, I'm going to get one more equation. So x square plus y square the whole square equals to minus 5 square plus minus 12 the whole square. Since we already know what is x square minus y square is and 2xy is, I'm just simply applying those values. So x square plus y square the whole square equals to 25 plus 144. So x square plus y square equals root over 25 plus 144, which is 169. And therefore we get x square plus y square equals to plus or minus 30. But how come x square plus y square be minus 30? That's not possible, isn't it? So we ignore the case of minus 30. So we consider only x square plus y square equals to 30 as our equation number 1, and x square minus y square equals to minus 5 as equation number 2. Now I'm going to solve the two equations. So let me take down the equation once again. So x square plus y square equals to 30. X square minus y square equals to minus 5. By elimination method, if I simply add the equation, I get 2x square equals to 13 minus 5. What is 13 minus 5? 8. So x square equals to 4. X equals to plus or minus 2. Now substitute x square value in one of the equation. Substituting x square equals to 4 in x square plus y square equals to 13. I get 4 plus y square equals to 13. Y square equals to 11. So y will be root over 11. Oh, y square, so it's not 11, it's 9 here. So we get y square equals to 9, y equals to plus or minus 3. Now there are two values for x and there are two values for y. We took root over the given complex number as x plus iy, isn't it? See, we took root over minus 5 minus 12y as x plus iy. Now, you will think which x and y should be applied here. Is it the positive form of x and y, or one positive, one negative, or both negative forms? Isn't it? So this will put us in a dilemma, which x and which y should be taken. Now for that, you need to look into this equation, the 2xy. So this is the most highlighting part here to conclude the solution. So for that, what do you see? You see the 2xy statement. 2xy equals to minus 12. Which means when 2xy equals to minus 12, this implies that product of x into y have to be negative. Product of x into y have to be negative, meaning one has to be positive and one has to be negative. So the square root of the given complex number is either plus 2 minus 3i or minus 2 plus 3i. Or you can simply write it as plus or minus 2 minus or plus 3i. Okay. So this is how we finalize the answer. So let me just rewind what I told you once again. So here they want us to find the square root of this complex number. We consider the square root of the complex number as x plus iy, squaring on both sides and then expanding. We get two relationships between x and y. Now this will not be enough to find x and y. So we use the conversion formula. Conversion formula, which is here. Using the conversion formula, we get another equations for x and y. Now take this as 1 and the one we obtained by equating the real term as equation 2. Solve 1 into, you find the value of x and then you find the value of y. Once you find x and y, substitute back into the x plus iy. But before that, check 2xy form. If 2 into xy is negative, so make sure that one is positive and the other one is negative. But if 2xy is positive, then both x and y have to be positive or both x and y have to be negative. So the next question is to find the square root of I. So I meaning 0 plus I, isn't it? So question is to find the square root of 0 plus I. So we consider that as x plus iy, like in the previous question. Square on both sides, 0 plus I equals x plus iy the whole square. So we get I equals x square plus I square y square plus 2xyi. So I equals x square minus y square plus 2xyi. Again, equating the real terms. Since it is 0 plus I, equating the real, you get x square minus y square equals to 0. And equating the imaginary, 2xy equals to 1. Now, as I said, this is not enough for us. So we need another conversion formula. The same thing, x square plus y square the whole square equals to x square minus y square the whole square plus 2xy the whole square. Now using that, we get x square plus y square the whole square equals to 0 square plus 1 square. And that means x square plus y square equals to 1. So this is plus or minus 1, but x square plus y square can't be equal to minus 1. So we ignore that. So we consider only this equation as equation number 1. Now that 1 we received by equating the real will be equation number 2. Now solve 1 and 2. Solve 1 and 2. X square plus y square equals to 1. X square minus y square equal to 0. I'm going to add the two equations, so y square get cancelled. 2x square equal to 1. So x square equal to 1 by 2. X is equals plus or minus 1 by 2. Now substituting x square in one of the equation. Mind it, it is x square, not x I'm substituting. So substituting x square in one of the equation, 1 by 2 plus y square equals to 1. So y square equals to 1 minus 1 by 2. Y square is also 1 by 2. And here, sorry, I forgot to put a root. So y will be plus or minus 1 by root. So we found x and y, but both of it are in x plus or minus form. Now again, we need to look into the 2xy forms here. 2 into xy, look at this. 2 into xy is in positive form. 2xy equals to 1. So product of x into y is positive. That means both x and y are positive or both negative. So the answer is plus or minus 1 by root 2 plus 1 by root 2i. Okay. So this is how we get the square root of a given complex number. This is important topic and supplementary topic for CBSE 11th standard, whereas for ISE it is there in your book itself. So it's a very, very relevant and important topic. Now let's get into the proof sums of this topic. Okay, so this is the first proof sums under complex number. It is given in the question that a plus ib equals to x plus I the whole square by 2x square plus 1, and prove that a square plus b square equals x square plus 1 the whole square by 2x square plus 1 the whole square. So this is the question. Now, so there are multiple ways to do this. One of the way usually everyone does is they square on both sides and they expand the given information. But that is not a wiser way. The best way is to take the conjugate. So let us rewrite the given complex number first. The given information, I mean. So a plus ib equals x plus I the whole square divided by 2x square plus 1. Now I'm going to take the conjugate of this complex number, which means I'm going to have a bar on top of this. So I'm going to conjugate the complex number. So what is conjugate of a plus ib, a minus ib? What is conjugate of x minus I the whole square? Well, it's x plus I the whole square. It will be x minus I the whole square divided by the denominator. But the denominator is not a complex number. It's 2x square plus 1. So therefore, no conjugate for that. It remains the same. So the given information, I'm going to take it as statement number 1. And the conjugate that I get is statement number 2. Now I'm going to do 1 into 2. So which means a plus ib into a minus ib equals x plus I the whole square into x minus I the whole square divided by 2x square plus 1 the whole square. So by multiplying 1 into 2 with this, I'm able to come to this step. So on the left side, you can see it is in the form of a plus b into a minus b, which is a square minus b square form. So a square minus I square b square. And whereas on the right side, it's x plus I the whole square into x minus I the whole square, which we can write it as x plus I into x minus I the whole square by 2x square plus 1 the whole square. And this is nothing but x square minus 1. So this will be a square plus b square because of the I square value, and here x square minus I square the whole square so we get x square a square plus b square equal to x square plus 1 by 2x square plus 1 the whole square. So let us see whether we are able to prove what they want us to prove. Absolutely. So this is one way of doing this proof sum, where a given complex number is given, you simply conjugate and then multiply the two. Now let me show you a next sum. Next proof question, x plus iy the whole cube equals u plus iv. Prove the following. Now, so here, since it's in a whole cube, the conjugate may not work, and as well as what we need to find is u by x plus v by y. So here I'm going to expand it. Alright, so expanding x plus iy the whole cube will be x cube plus 3x square iy plus 3x I square y square plus I cube y cube equals to u plus ib. Now x cube is a real term, will remain as it is. 3x square iy is an imaginary term, nothing to simplify, so I keep it as it is. Whereas for the next one, I square is there, so which is minus 1, so it's 3xy square. And the next I have an I cube is minus I, so I get minus y cube equals to u plus iv. Now equate the real terms. What are the real terms? This and this are real. So x cube minus 3xy square equals to u. Then equate the imaginary terms. What are the imaginary? The one that has I. So this has an I. Sorry, I left an I here. So there is an I here. So you get 3x square y minus y cube equals to v. Alright, I can take x common now. So x square minus 3y square equals to u. So x square minus 3y square is equal to u divided by x. Likewise, taking y common out, 3x square minus y square equals to v. So 3x square minus y square equals to v by y. And look at what we need to get. We need to get u by x plus v by y. So let us simply add the two statements that we want. So adding this and that, which means let's take it as 1 and let's take this as 2. So I'm going to add 1 and 2. On the left side, I'll get u by x plus v by y. On the right side, I get x square minus 3y square plus 3x square minus y square. So that is nothing but 4x square minus 4y square, right? So u by x plus v by y equals 4 times x square minus y square. Now see whether we're able to prove. Yes. Look, this is what we need to get, and we got that. So that's it. I'm done with to selectively important proof sums and finding the square root of the complex number. There is already a video made for polar form of a complex number, which will be considered as part 3, and then we will have one more video on complex number where we'll discuss how to find x and y using the given information. So hope the videos are useful to you all. Thank you.